Hello, Miss Walsh here. So we're going to do example 2 from day 2 on optimization. Okay, Danyan has a backyard, consists of a triangular swimming pool, and I wish. Okay, and concrete tiling surrounded his triangular backyard has a total area of 900, so that the whole thing is 900. The width of the concrete tiling east to west, so the whole thing is X, and then there's some concrete, 3 meters. The height of the concrete tiling, north to south, 2 meters on the south, and then 4 meters on the north. The width of the backyard, east to west, and then X is restricted to be this. Just take a moment and process it. I'm just going to keep moving so it doesn't end up being too long. So write down the expression for the width of the swimming pool in terms of X. Okay, well, this is going to be our width, and so then the whole thing is X. And so it's just going to be taking off 3 from both sides, and we end up with X minus 6. Okay, the second one, find an expression for the height of the swimming pool. Okay, the tricky of the swimming pool, so that's this thing right here, right? Okay, well, what do we know? What can we use? I don't know. We know, though, that the whole area is 900. So what we're going to do is we're actually just going to use the whole backyard, okay? So we know that this is just a triangle, so we're going to use the formula for the triangle, and then it's half times base times height. You know that the area is 900, and then you know that your base is, and the base here is actually X, not X minus 6, because right now we're using the whole thing. So this is X, and then this is H. So they want the height, so now just multiply both sides by 2, and you get 1800 is X times H, and then divide both sides by X. And so what you end up with is you end up with 1800 over X for the height. So that's this. Okay, super. Hands show, so therefore we're going to have to use it, that the area is this big ugly thing. Okay, be careful. A was defined not as the whole backyard, but as the swimming pool, okay? Well, this is not such a big drama. We can do this. So you got your area again. So now we're just going to do this for the pool, okay? So area of the pool, and that's going to be half times base times height. Okay, and we don't know what the area is, but we know that the base is X minus 6. Remember, that's that. And then we just found that the height is 1800 over X. So this is going to be, algebra. Algebra. Okay, so what we're going to do is just leave the half alone, and let's just FOIL. Do you remember your good old foiling skills? Outer, inner. And then, oh, yeah, that's it. It's not actually FOIL. Just multiply it through. Never mind. No, I lied. I made a mistake, but I'm not redoing this. So be careful, because the whole height is not this. The whole height, I apologize, we need to take off the 4 and the 6, okay? So, hey, I was checking if you were paying attention. The height of the pool is going to be the height of the whole backyard, but we're going to have to take off 6. That's why I remembered the FOIL. So just add on 6 to this, okay? And now this is what we do. All right, so your area is 1/2, and then this is going to be 1800. So this is going to be 1800 X over X, which will just cancel. This is going to be minus 6X. This is going to be, God, a really big number. That's my mathematical precision. So this is going to be, be careful, it's negative, yes. So don't panic. We still got a half there to save us. X, and then this is going to be plus 36. Okay, and so now what we're going to do is we're going to work in the half. Whoop, whoop, whoop. And so we're going to have, dum-da-da-dum. So the first term is going to be 900. Yay! And then the next term is going to be 3x. Check it out. Keep your eyes on the prize. Looking good, boys and girls. This is going to be half. Check it out. Half of 10,800 is 5,400. We're geniuses. 5400 and modest. Okay. And then this is going to be plus 18. And so then you can take that step on your own. 900 plus 18 is going to give you this, and then you got it. And then you can feel like a show that genius, and that's 5 marks right there. So it's doable, but it's difficult. All right. Find the possible heights of the width and find the possible width and the heights if the area of the swimming pool is 648. Okay, what's important to remember is even if you had no idea how to do this first part, you can totally get the rest of these marks. So what they're saying is hey, this is the area of the swimming pool. What can my solutions be if the area is fixed to be to 648? So I've already entered it. You pause and enter it. I just don't want to drag this on for too long. And so then you know what to do, right? This is an intersection question. All we're going to do is we're just going to throw it into, this is going to be thrown into F1. This is going to be thrown into F2. Then this is, okay. And then you are going to have 2 points where they intersect. Okay, so just be careful. So there's the intersection of 30. And then function intersection, there's the intersection of 60. Remember what x is. X is our width, okay? So then our width can be 30 and our width can be 60. Now what you need to do is you need to find the heights, okay? So let's go back to our expression. And then where's our height expression? Our height expression is going to be then 1800 divided by x, right? That's the height. So then 1800 divided by 30 will actually, so 1800 divided by 30, that's going to be 60. And then reciprocating that, 1800 divided by 60 will give us 30, okay? So this is our 2 possible sets for the heights and the width. Okay, great. And drawing a sketch is always good. So I'm going to just model that. You remember that like this, and then this is your 648. And then you show where the 2 solutions are, and then just make it easier for the examiner to give you those marks. Okay, C, find the expression for the derivative. Okay, so again, before I take the derivative, I am just going to pull this up, like just right up here, because then people forget and then they derive and whatever. Anyway, so dA over dx, and then 918, remember constant, gone, minus 3x, this is going to be minus 3, and then this is going to be minus. When you drop the minus, that is going to turn into a plus. 5400 x minus 2. Done. Hence, okay, remember hence means you need to use this. Find the value of x that maximizes the area, okay? So you can see there's a pattern, right? When you have a maximum, then your derivative is always 0. And so we're going to set dA over dx to 0. And now you can just solve this. So I'm going to uncheck this. This I don't need anymore. Minus 3 plus. Okay, this is not looking great, but doesn't matter. We just need the root, yeah? So just find the root, and there it is. It's 42.4. Okay, and again, I would draw a sketch, so it's like something like this. And then x is equal to 42.4. So that's the value of x. And then what it says is find the maximum possible area. So remember on the sketch, yeah, this is not area. If you graph the derivative, this is all the slopes. So what we need to do is we then need to graph the original to find the max area. So we're going to go back to A. And then, see, that's why it's smart not to delete things. We still got it. Oh, yeah. All right, so now we're going to plot it. And now all we need to do is we need to find the max. Now, you notice that it happens at this number, duh. That was the point of setting derivative to 0 in the first place, okay? So what you have is you now have as your max use a different color. Let's use purple. And there's your max at 42.4 and 663.442. And then the maximum area. This graph is for the X and the A. And so this is going to be, the area is, you can put the approximation signs, 63. That's like a pretty big pool, right? I guess it has to be for us to swim in it. All right. Okay, so again, do this again, and then try to do it faster. Like, this is one of these more difficult problems, and I hope that it helped. Ciao, ciao.